All right, today we're learning solving quadratics. Solving quadratics. And we're doing it by factoring. Solving quadratics by factoring. Okay? So what is a quadratic? Well, the basic formula for a quadratic is ax squared plus bx plus c. That is the format that a quadratic should look like. So if you're given, for example, x squared plus 17x plus 62 equals 2x plus 6, well, we cannot solve this quadratic because it's in the wrong format, or we can't solve it easily. So solving it means looking for the x-intercepts. If we were to actually graph this, which some websites will graph it, you're looking for the x-intercepts. So you can solve it visually by looking for wherever this would cross the x-axis. But today we're doing it by hand by setting the whole equation to 0, because this is the 0 line, ground zero, where y equals 0. We could find the x-intercepts. Remember, this is y is at 10, y is at 5. This is y is at 0. So wherever y is 0, we can find the zeros, the x-intercepts. So we have to set this whole equation equal to 0. So in order to do that, you can draw a line if you'd like. You don't have to, but we want to subtract the 2x because it's on the wrong side, and also subtract that 6, it's on the wrong side. Draw your equal line. 2x minus 2x is 0x, so you got rid of it. If you subtract 2x from this side, you have to subtract it from here over here as well. And then 6 minus 6 is 0. Right? The whole point was to zero it out, to get rid of it, because we want 0 to be on this side only. If you subtract 6 on this side, you have to do the same thing on the other side. Subtract 6 over here as well. So if you want to, you can square this or make it colorful to help you see it better, and then circle your constants. Make sure you're lining up like terms, right? These are x terms, constants here. So 17x minus 2x is 15x, positive 15x, right? 62 minus 6 is a positive 56. Drop that x squared down. So now we have the correct format we can work with to easily find the zeros. You could actually graph this, because a lot of websites actually won't graph this format, but it will graph this. You could graph it and it'll show you your zeros are actually over here somewhere. Actually, it would show that to you. You can graph it, but today we're learning how to do it by hand, right? So if you see a quadratic, x squared plus 15x plus 56, you can ask yourself this question. As long as this coefficient of the x squared term is 1, right, the a value, number in front, there's one of these, x squared, so you could also write it as 1 x squared. You don't have to, but that helps you out. This is the same equation, right? So as long as this x squared coefficient is 1, you can say what times what gives me 56, but add it gives me 15. So make a chart. What times what gives me 56, right? But added gives me the middle term, 15. Okay, that coefficient there. So you might need to list out some factors. 1 times 56, do all of them. 2 times, is that 28? 28. Does 3 go into there? No. 4 might go in there. 4 times 14, I think. Let's think about which of these numbers will give you 15. 5, 6. The infamous one, 7 times 8, right? 8 times 7. Oh, there we go. Look at that. 7 plus 8 is 15. It's a puzzle, right? There is the missing link. So use your magic numbers and go ahead and create your two binomials. So x plus 7 times x plus 8 is your answer. Those are your factors, okay? These are your factors. There's factor 1, there's factor 2, right? You can always double check yourself. X times x is x squared. X times 8 is plus 8x. 7 times x is 7x. 7 times 8 is 56. Is that the same thing as our original standard form quadratic, that polynomial? Yeah, it is, right? That's 15 right there when we add it together. So you did it correct. So you can always, make sure you always check your work. I want to see arrows on your paper. But these are your two factors. This is great, but it's asking for the x value, okay? The x-intercept. So what you can do, we need to do next is set each factor equal to 0. So set this factor equal to 0. So set each binomial equal to 0 and solve for x. What number plus 7 gives you 0? Well, subtract 7, right? Show your work. Well, negative 7 plus 7 equals 0. So there's your first factor. What number plus 8 equals 0? Yep, negative 8. You got it. Subtract your 8. You'll get negative 8. So there's your two answers. Your factors are x plus 7, x plus 8. Your solutions, your x-intercepts, zeros, all those words, roots, are negative 7 and negative 8. I'll give you another example. Say you have instead x squared minus 3 equals negative 4x minus 2. It doesn't matter, right? You cannot solve this easily in this format. It has to be where the equation's set to equal 0. Is this equal to 0? No, it's not. So draw a line down if you like. How do you undo subtracting a 4x? You add a 4x. So do the opposite operation. This was 2x, so you subtract 2x. This is a subtracting 4x, you add 4x. What's negative $4 in your bank? Add $4. You're on a 0 balance, right? 0. Subtract 2, we gotta add 2 to get rid of it. Bam. So all that equals 0, right? Well, if you add 4x on this side, you have to add 4x over here. If you add 2 over here, you have to add 2 over here. So here is x squared. Make sure you're coding your terms so I can see it. There's negative 4x. This is not negative 4x. This is not an x term. This is a constant. The only x term is this negative 4x, so that just comes down by itself. And then circle your like terms, your constants. Negative 3 plus 2 is negative 1. Okay, so that's an example if you have a problem like that. Let's do another one. X squared minus, I'm just making up something, plus 4 equals, I don't know, it doesn't really matter, 3x plus 6, right? This equation's not where it's equal to is 0. So you gotta move these terms from that side, gotta delete them. So this is 3x, you wanna subtract the 3x because 3x minus 3x is 0. That's a 6 here, right? So you wanna subtract a 6 to get rid of it, that's 0. So we got 0 over here. If you subtract 3x from this side, you have to subtract it over here. You gotta subtract the negative 6, over here, right? Subtract 6 over here. And then circle your like terms. There's its own term, x squared. This is the only x term. Oops. I meant to put plus 4 over here, excuse me. If you add 4x over here, you have to add 4x over here, excuse me, just like over here. If you subtract 2x here, you have to subtract 2x here. This was subtracting 4x, so you had to add 4x. You have to add 4x over here. That was just a mistake. Okay, so you got 3x here, so you have to subtract 3x, right? So subtract 3x over here. This is the only x terms, so that's its own situation. These are both numbers, so circle those. I want to see you coding today if you have trouble understanding this concept. X squared, bring down your box, negative 3x. Bring down your constants, 4 minus 6 is negative 2. And there you go. So x squared plus 4 equals 3x plus 6 is the same thing as x squared minus 3x minus 2. Do you see what we did? We subtracted 3x. 4 minus 6 is negative 2. So that's how you rewrite your equations in standard form. This is standard form. Okay. Your next step will be grouping. So let's do an example when you have two groups. What if you're given 3x squared minus 9x minus, what if you're given 3x squared minus 11x plus 6 equals 0? Okay. What if you're given 3x squared minus 11x plus 6? This is going to require a grouping method. So if this number is not 1, if there's a number here in front, you have to multiply a times c. What times what gives me a times c, but add it gives me b. Remember, this is a, this is our b value, and this is our c value. A times c, 3 times 6, a times c, 3 times 6 is 18. What times what gives me 18, but added gives me b. Negative 11 is b, the b value, the coefficient of our x term. Well, let's try some numbers. 1 times 18, is that 11? No. Remember, this is negative as well, so think about that. 2 times 9, is that getting to 11? Maybe. 6 times 3, right? List all your factors. So I think we found it. 2 times 9, right? Is 2 plus 9 negative 11? No. So what do we have to do? Oh, negative 2 times negative 9. That works. Negative 2 times negative 9 is a positive 18. But when you add the numbers, remember it's a puzzle, it's negative 11. So we found our magic numbers, circle them. When you do this a times c thing right here, you have to group. So you rewrite your middle term with your magic numbers. So negative 2x minus 9x minus 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 minus. So rewrite this with this, right? Plus 6. So rewrite your equation, or you rewrite your middle term with your magic numbers. But that's the same thing. Negative 2x minus 9x is negative 11x, right? You have 4 terms. 1, 2, 3, 4. So split. And then take out your GCF. So what goes into, what's common between between a 3x squared and a negative 2x? We could take an x out. You're left with 3x because x times x is x squared. And then you're left with this negative 2. Okay. Bring that negative down. What can you take out of a 9 and a 6? You could take a 3 out. You're left with 3x plus 3x minus 2. How do you know that? Negative 3 times 3 is negative 9. There's the x. Negative 3 times a negative 2 is a positive 6. Circle your outsiders. Code your insiders. Okay, group your outsiders. Group your outsiders. Group your insiders. And there's your 2 factors. If it's asking for the zeros or x-intercepts, you have to set each factor to 0. Add 2. 3x equals 2. And then divide by 3. X equals 2/3. That's 1 x-intercept. Add 3, x equals 3. Okay, so that's solving by factoring. the next delta math will be simplifying by taking out your GCF. So say you have 7x squared minus 8x. Your question is, what do these two terms have in common, right? You got x squared, which means x times x, and you've got an x over here. What do these two situations have in common? They both have an x, right? So take an x out. If you do that, you're left with a 7. You took an x out, you're left with one of those left. Minus, you're left with an 8, and there was no x's left. You took out 1. Double check your work. 7 x times x is x squared. You're timesing that. Times this. X times negative 8 is negative 8x. Okay? So this is a factored form of 7x squared minus 8x. What does that mean? Well, here's an example. Is 18 the same thing as 6 times 3? Is 18 the same thing as 6 times 3? Yeah. But do they look the same? Do they look the same? No. But they are the same value. 6 and 3 are factors of 18. They're numbers that multiply to give you 18. These are two terms that multiply to give you this polynomial. If you take an x times a 7x minus 8, you will get 7 times x squared minus 8x. So you're just breaking it down into its factors. Let's try another one. 70a minus 8a minus 80a cubed. 70a minus 88. 70a minus 80a cubed. That's a tongue twister. So what's in common between a 70 and an 80? You can take a factor of 10 out. They both are dividing, both you can divide by 10. What's in common between an a and then a cubed? Well, just that a. Take the smallest a out. That's the only thing that's in common. 10 goes into 70 7 times. There's no a left because you took it out. 10 goes into 80 8 times. You took one out, one a out, so you have 2 left. So look at it. Look at when you multiply it back. 10 times 7 is 70. There's your a. Minus 10 times 8 is 80. A times a squared is a cubed. Okay? Just double check your work in the moment. But that's your factored form. So you can call this a factored form, factored format. And there's your standard form of this polynomial. Okay? Standard form. So that's how you factor out. We could try another one. 40x squared minus 48. Well, does this term have an x in it? Yes. Does this term have an x in it? No. So x is not in common, so x will not come out. You take out what's in common. This is what your common value is, your GCF, okay? The greatest common factor. This is what's in common. There's a 10, a factor of 10 in common between these two. There's an a in common. Is there an x in this box? No. So x squared will not come out. It will stay inside the parentheses. But there are factors that are in common between 40 and 48. So you can do it out on paper, unless you could do it in your head. List all your factors of 40. Okay, what numbers on both sides that are common? 40 and 48 both can be divided by an 8. That's the biggest number, the GCF, greatest common factor. So let's take an 8 out. That's all you can take out. What's left? 8 goes into 45 times. The x squared stays inside. 8 goes into 48 6 times. That's the factor the factorization of 40x squared minus 48. It's 8 times 5x squared minus 6. All right, so that's how you factor out GCFs, and that's how you solve quadratics by factoring. That was a lot, I know, but you can do it. So that's about it. Bye.